That's right, it is Mike Hagan, and you are listening to Radio Orbit on KOPN Columbia. Okie dokie. My guest this evening is extremely close to my heart. His name is Dr. Dennis McKenna. Dennis has over 30 years of interdisciplinary experience in the fields of pharmacognosy, ethnopharmacology, neurology, and ethnobotany. He holds a master's degree in botany from the University of Hawaii and a PhD in botanical sciences from the University of British Columbia. His doctoral research focused on phytochemical and pharmacological investigations of Amazonian ethnomedical plants, and he has since conducted extensive ethnobotanical fieldwork in the Peruvian, Colombian, and Brazilian Amazon. He's a remarkable person. He's a friend and a returning guest to Radio Orbit. So without further delay, we shall say hello and welcome back to Dennis McKenna. Hi, Dennis.
Hi, Mike.
How are you this evening?
Nice to be here again.
You're welcome. Thanks for being here, and we hope you're having an enjoyable evening out there on the west coast of North America.
Well, it's a typical rainy day here in British Columbia.
Is that right?
Yeah.
It's funny. I talked to a friend of mine in Seattle today, and not far from you, he mentioned the same thing. So, well, look, Dennis, it has been over a year since we talked last on the air. So, first off, as much as you'd like to say, I'd like to ask you about your recent move to Vancouver and a little bit about your new adventures there in Canada.
Okay, well, yes, it's been just about a year since I relocated up here, and so far so good. It's been an interesting year. It's been a learning experience. I think deciding to move to another country has always got its challenges.
I'm sure.
But so far, so good. It's kind of an experiment, I guess, in expatriatism. But of course, I, as you mentioned, I got my degree here at UBC 25 years ago.
Right.
So I know Vancouver, I know British Columbia, although Vancouver is a different city than it was 25 years ago.
Yeah, I was going to ask you a little bit about the scene there in Vancouver. I've heard lots, but I've never actually been there.
Well, it's a great place. It's a very cosmopolitan, high density, very ethnically diverse city. It's probably one of the 5 or 6 world-class cities. It's one of the most beautiful cities in the world. But when I started here as a graduate student in 1979, so far back it's hard to imagine. It had the air of a kind of a quaint, stuffy English village. And now it's like Hong Kong or
Amazing.
Tokyo or something like that. There are a great many more Asians because of the much of it because of the Hong Kong exodus in 1997. Many people brought their fortunes to Vancouver, and it changed the face of the city.
Wow, interesting.
Yeah, but that's a good thing, actually, especially if you like ethnic cuisine, which I do. You've got a lot more choices around here now. So it's a great place.
All right, and the actual work that brought you there is for the Institute of Technology there, is that correct?
Right. I joined the BC Institute of Technology, not having the cachet, I guess, to get a position at UBC. I accepted this job in the Natural Health Products Research Group here, and the BC Institute of Technology is basically a polytechnic school. They teach a lot of classes and how, for people to get skills, get certifications in various types of trades and so on, but they also are committed to research, and they're trying to get a research program going. So I'm in actually one of the longer-lived research programs here, the Natural Health Products Research Group. And up here in Canada, what we call dietary supplements in the States, herbal medicines and so on, are classified as natural health products. So it's an important distinction because the way those things are regulated is quite different.
Right, that was my next question. What is the difference?
Well, the difference is dietary supplements are considered a kind of food, and natural health products are considered a kind of medicine. So they're regulated more like a medicine, which, of course, herbal supplements are medicines, really. So the Canadian regulatory framework is a little closer to reality and acknowledges the fact that these things are used to treat diseases. That's not a claim you can make in the States.
Right.
You can't claim that something is used to treat or prevent a disease, although, of course, that is how they're used. Well, in Canada, they acknowledge that up front, and the laws are a little different. For example, you have to support your claims with a much greater degree of scientific evidence than you do in the States.
Mm-hmm.
So it's a different regulatory climate. I think it's a good model for for the way this is going. It's closer to the European model, and of course Canada is really part of Europe in terms of just kind of the general mindset of the country. It's really a European country,
right,
still highly influenced by ties to Britain and so on. I mean, the Queen is still recognized as the head of state in Canada.
Right. What do those regulatory laws, how do they affect accessibility on the other side, on the consumer side?
Basically, not much. You can get just about any dietary supplement here that you can get in the States. But the level of, there's a higher degree of quality control, there's more scrutiny of adverse events.
But it's still OTC.
Oh, yes,
Yeah.
Absolutely. They're OTC, that's right.
Okay, all right. Very interesting. A person on the in the chat room right now just puts up a note about Codex Alimentarius.
Right.
Are you familiar with this? I think you and Richard and I may have spoken about that last year, Richard Glenn Boyle.
Yes.
But anyway, maybe you could mention something about that.
Yes, well, yes, I am to a degree. Codex Alimentarius is the kind of framework for the regulation of these products.
Some people are very afraid and very nervous about that whole.
Yeah, there's a
particular
great
thing.
deal of nervousness about it, that it's going to make it impossible to go out and buy vitamin C, for example, or that for doses of vitamins and minerals above a certain minimal dose, you'll have to get a prescription. And quite frankly, I'm not sure that that's going to happen. I hear both sides. I have friends in the industry in the States who say, this is never going to trump our own laws, and basically we have to adhere to our own laws, and Codex Alimentarius is not going to make a difference. But other people are saying, no, it will take over. It's part of the globalization strategy. It's all being, sort of mounted through the World Trade Organization, and conspiracy on the part of the pharmaceutical industry to take over the herbal industry. There's a great deal of misinformation, and I don't really know the answer. I don't think we're quite there yet, although it may happen. It may come in the next few years.
Okay.
But, it's really a question of what will people put up with.
Mm-hmm. Yeah, that's really what it comes down to on a lot of fronts, I guess.
Right, and as we know, people will put up with a lot, and
Remarkably so.
Our legislators will put up with even more than the people will put up with. So it's hard to say. I mean, unfortunately, in the regulatory climate, in all of these things, money talks, and lobbyists pretty much get what they want, and the rest of us who don't have deep pockets or lobbying budgets more or less have to go along with it. So this is, one reason why people need to become more active, although sometimes it seems, like it's a zero-sum game, but it's either that or give up.
Right.
And we're not about to give up.
Certainly not. All right, speaking of not giving up, we do have allies, and some of them are not human. And I'd like maybe to talk a little bit about perhaps an update on your work in Peru and the plant compounds that you've been researching down there, and I guess maybe a question about whether that work is continuing there at BCIT.
Yes to the last question. It is continuing. I have, as I think I mentioned last year, I have had a grant for the last 3 years from a private research organization to investigate Amazonian ethnomedicinals, I guess you could say, as potential treatments for schizophrenia. That is the rationale of the grant, and I'm now on the 3rd year of what is to be a 3-year grant. However, due to bureaucratic snafus, it took a year to get the grant transferred up here from the University of Minnesota where it was.
Right.
So now they've extended it for a year, not with any additional funding, but just in order to have time to run it out, to complete the work that that we'd started. And so now it is transferred, so now I'm back at work on that. And it's gone from the field stage. Initially there was quite a bit of field work, collecting plants and so on. Some of that is still going on, but we've had some very successful collecting expeditions. So we've got out of our initial list of 250 candidate species that we wanted to look at, we have got about 150. So now we're in the process of sorting all that out in terms of their chemistry and their biological activity. We're using receptor binding assays, which are a sort of simple, quick, and dirty way to look at an extract to see if there might be something in that mix that binds to or that interacts with a receptor, a neural receptor of interest. And so this is a way to take a crude extract and kind of profile it or fingerprint it, if you will, to see if it tweaks any of these receptors of interest.
How do you do the assay? Is there an animal involved, or is it a human?
No, the assay is actually dead simple. Once you get it set up, it's a simple matter of you take a radioactive drug, a drug that has been labeled with an isotope, such as tritium, that you know is selective for a particular type of receptor. In the realms that we've discussed, for example, the hallucinogen DOB or DOI. These are some of the compounds that Shulgin synthesized. Very highly selective for a certain kind of serotonin receptor called the 5-HT2A receptor. That seems to be a common receptor that almost all hallucinogens interact with. They may interact with others as well, but that seems to be the key receptor. So if you can get a label on something like DOB or DOI, which happen to be halogenated for the chemists among you, which means it's very easy to put a radioactive form of bromine or iodine on those things. So then you basically take a rat brain homogenate or a homogenate of tissue, you put it into some buffer, you incubate it, you add the radioactive drug, and it binds specifically and selectively to the 5-HT2 receptors. Then you put in your unknown drug, or in this case your crude extract or a fraction from your extract, and you measure the concentration it takes to knock that label off. In other words, what is the concentration of the cold drug that it takes to displace a certain amount of the label? And if it only takes a little concentration, then you know it's pretty selective for those receptors. So, the same techniques. You just vary the labeled drugs that you use, you vary the tissues. So you can look at, roughly 60 different kinds of receptors once you get the assay set up. And you can rather quickly screen quite a number of compounds or quite a number of extracts. I should say having said all that, I've done a lot of receptor binding work in my day, back in the day, but most of this work, this initial screening work, is being done by my colleague, Dr. Brian Roth, at UNC Chapel Hill.
Yeah, you've mentioned him before, sure.
Yeah, he is the person that worked out the pharmacology of salvia divinorum, and the person who figured out that salvia divinorum, that salvinorin A, the diterpene, is very selective kappa opiate, very selective for the kappa opiate receptors. But what he does in his spare time, I guess, is he's the director of the National Institute of Mental Health, has a psychoactive drug screening program, and so researchers can submit anything as long as they have a legitimate reason to. They can submit an extract or a compound that they have synthesized or something that they've isolated from a plant or an animal, and they can just submit the sample and say, please screen against the following bank of receptors, and you specify which receptors you want them to look at. And it's very useful because they screen thousands and thousands of compounds, and they're very good at what they do. They know how to do it, and they have all these assays set up.
You bring up salvia, and I had a question here on my list that's sort of down toward the bottom. I thought we might get at it later, but since you mentioned it, I'll ask really quickly. A number of people have sort of caught on to the salvia thing in the last couple of years, even though it's been around for quite some time, but I think it's getting more into the mainstream consciousness perhaps in the last few years. But anyway, could you do a quick description of it and maybe compare it to, I don't know, something like, it sounds more like a DMT flash or something like that to me, but I've never done it, and I thought maybe you could just tell people a little bit about it.
Yeah. Well, yes, I could. Actually, before I do that, for those who might be curious about what Brian Roth does, I'm looking at his website here. This is for those that might want to just see what's going on. It's a pretty interesting website.
Yeah, please give us the
and
address.
The website to this psychoactive drug screening program is http://pdsp.med.unc.edu. pdsp.med.unc.edu. Right.
Okay, that's Brian Roth.
Not a very memorable name, but it's the psychoactive drug screening program at the medical school at University of North Carolina at Chapel Hill.
Okay, all right.
Where he's located.
All righty.
So if you go to that, that's the home page, and then you can see, the kinds of data. Most of their data is online, and because Dr. Roth is the sort of, I guess now, the world's expert on salvia, he gets interviewed a lot, and there are interviews with him on from NPR and so on.
Okay.
Just for those that are interested in the pharmacology of these things, that might be useful to know about that website.
Good. I just posted it up there on the website. Okay.
Now, when it comes to salvia, salvia it's like DMT in the sense that it's short. When the leaves are smoked, it's a very short-acting experience, only about 15 minutes, which is the same time frame as DMT when DMT is smoked. But in almost every other respect, salvia is different. For one thing, it's not what I call a true psychedelic. DMT, LSD, psilocybin, mescaline, DOB, all of these things are true psychedelics in the pharmacological sense. They are 5-HT2A agonists. Where they hit this very selective
receptor
group of serotonin receptors as well as others. So salvia is a completely a critter of a different color. It hits the kappa opiate receptor. There are basically three major types of opiate receptors. the kappa, the delta, and the mu receptors. The mu receptor is the one that morphine, for example, is most selective for, although morphine is very unselective. It interacts with all three types. Salvia divinorum, or rather salvinorin, the diterpene in salvia, hits only the kappa receptor. And in that respect, it's quite unusual for a drug because most drugs hit multiple receptors, at least to some degree. And what's quite remarkable about salvia divinorum, it's apparently highly selective only for the kappa receptor, the kappa opiate receptor, and no other receptors, no other opiate receptors or any other kind of receptor.
Is it active orally too? Can you eat the stuff?
It is not apparently orally active. It is so-called buccally active in the sense that you can chew a quid of the leaves. This is how it's traditionally taken. The fresh leaves are chewed, but the absorption is through the mucous membranes in the mouth, not through the gut.
I see.
And then, of course, the diterpene itself is volatile, so the dried leaves can be smoked, and it's absorbed much more quickly, and it passes away much more quickly. And in terms of effect, it's more like a dissociative anesthetic. Its effects are similar to something like ketamine, in the sense that it causes sort of a complete dissolution of reality, often a feeling that you're out of your body. It's extremely bizarre, the effects. I'm not an expert on the effects. Many people are more experienced with it than me, and partly the reason for that is that I don't care for it. I mean, even an old psychonaut like me finds this stuff highly peculiar. And one aspect of it is, what do you bring back?
Yeah, what do you get out of it? Sure.
What do you get out of it is the question. And I don't get much out of it other than just a feeling of, gee, that was weird.
Gee, that was strange, sure.
Much the same could be said of DMT in the smoked form. DMT is a true psychedelic. When it's smoked, though, the effects are so overwhelming and so fast that by the time it's over with, you're sort of just left shaking your head and saying, my God, I know something profound happened, but what was it?
Right, it's so quick it's hard to hold on to.
Which is, of course, with DMT, one gets around that with the whole
ayahuasca
business, which DMT in the orally potentiated form lasts much longer.
Okay. All right, real quick before we take a break, Hefter. How are things at Hefter? Are you still involved?
Yes, I'm absolutely still involved with Hefter, and things are going very well.
Good.
Excuse me, I'm hiccuping here. Yeah, things with Hefter are going well. We're continuing to try to raise money, and we're sponsoring several different clinical studies. The notable one right now that is still actually in the winding up stages is Charlie Grobe's, Dr. Charles Grobe's study with psilocybin in terminal stage cancer patients to look at anxiety to help as an adjunct to psychotherapy and dealing with the fact that people are dying. Very positive results are coming out of that. And there are now 2 other studies that are about to start, which we're partly supporting. One of the encouraging developments on all this is that because the terminal cancer patient study has turned out so well, and we pretty much established that psilocybin is safe to give to people even in a fairly severe state of compromised health. It's an inherently non-toxic compound.
Yeah, probably helps.
So it's opened up the possibilities that the sort of inclusion criteria for the next trial will not be limited to terminal patients. It can actually be expanded to patients who are not necessarily terminal, but may be having difficulties dealing with their illness and the resolution of all that. So it opens it up to a much wider
group of
patient
potential
population.
Patients, yeah.
And it's just another step on the road to the notion that in the not too distant future, these options may be available to people. I mean, sort of on the political side, the whole rationale of doing this, but other than simply doing the research, which is worth doing in itself, but on the political agenda or the medical agenda, the idea is that if you can do some clinical studies, show that a compound like psilocybin is both safe to use and effective for what it's being used for, then you can apply to the FDA for orphan drug status, and you essentially can create a situation where, you know, you can have medical psilocybin, just like we have medical marijuana, which of course is, you know, implacably opposed by the federal government, but endorsed by a number of states.
Right.
Hopefully the FDA has not been so politicized that the decisions will be based on politics. There are still some in the FDA who cleave to science, and our experience has been, at least the group we're working with, you know, if we show the evidence, then they'll give the approval. So that's the hope. That's the kind of steps that this thing has to go through before it's available for general practice.
Okay. Well, it's a better position than we were in a couple of years ago, for sure.
Yeah.
In spite of the political climate, you know, as a matter of fact. So.
Right. Well, sometimes the most unexpected developments happen in the worst of times.
Isn't that the truth?
So.
Okay. All right, look, let's take a little break, okay?
Okay.
All right, we'll come back in just a minute. Everybody, it's Mike. You listen to Radio Orbit on KOPN Columbia, 89.5 FM. My guest is Dr. Dennis McKenna. You can find information about Dennis. Well, probably the best thing is just to go to my site, and there's links to lots of different areas where Dennis can be investigated. Over there at Hefter, also at Arrowwood, there's an interesting page about Dennis, and of course there's some stuff over at BCIT, or just go to your favorite search engine and put in Dennis McKenna, and I'm sure you'll come up with as much as you can handle. All right? Good to be with you all tonight, about 11:45 now on the 1st of October. Can you believe it? 2007. The time just rolling right along, as it tends to do these days, but we're into the last couple months of the year, and we're going to close them out in wonderful fashion, starting tonight with Dr. Dennis McKenna, good friend of ours from the program, here from Vancouver, British Columbia, and back with us right now. Hi, Dennis.
Hi, Mike.
Yeah, I want to shift gears just a little bit and ask you a question that has been on the minds of quite a few of our listeners, as well as myself. And it has to do with technology and nature. You know, as I do this radio show, Dennis, I talk to lots and lots of people doing all kinds of different things. And, you know, there's lots of different ways to classify people and ideas and this sort of thing. But I notice sort of two camps that are very strong about their beliefs right now. And they're sort of the one is the back to nature camp, which says you have to deny technology, resist technology, pretty much throw away the stuff that has sort of gotten us into the situation in many cases where we find ourselves. And then there's the other camp that is sort of the opposite of that says, you know, technology is what it's all about, and nature essentially should be either discounted or considered, you know, a bitch to be reckoned with and dominated. I guess the question in quick fashion is, can they coexist in harmony, or does it have to be one or the other? How do you see?
Well,
these
I
things?
think it's a false dichotomy. You know, because they do, obviously they have to coexist in harmony.
Right. And everything is natural. Right?
Right. We are part of nature, and I think a lot of the hubris and the problems that we've created for ourselves is our failure to recognize and acknowledge this. You know, that we are part of nature, and we have to live in a way that is harmonious to nature. Nature is not simply for us to exploit. it doesn't work that way. Nature, that's been the model for the last, essentially since the founding of the Industrial Revolution, and now we're beginning to see the consequences of this sort of rapacious approach to nature. If we keep it up, it's obviously not sustainable, and there is no miracle technological fix. But having said that, I think that technology is always part of the solution. It's definitely part of the solution. Even technology, though, is part of nature, because we are part of nature, and it's the human mind that dreams these things up, these technologies. I'm reminded of the often repeated debate about natural versus synthetic compounds, in the natural products industry. Natural is somehow better. But they're overlooking the fact that even synthetic compounds were made by completely all-natural organic chemists, who are part of nature.
Right, we can't get away from it.
You really can't get away from it, nor do you want to.
Right.
Nature has a tremendous amount to teach us still, and it's not in our interest to destroy it. It's in our interest to sustain it, because we can't live without it. If you simply look at global warming, all of the environmental crises, if you think about our relationship to the plant kingdom, it's as simple and stark as that.
Right.
Plants absorb carbon dioxide. They release oxygen. Without oxygen, we wouldn't be here to talk about it. And plants are the main source of oxygen in the atmosphere. So we're involved in a symbiosis with the plant kingdom, with the biosphere, a symbiosis, maybe more accurately, a kind of parasitism, because plants could get along fine without us, but I'm not sure. In fact, I know for a fact that we could not get along without them.
Right. Not only do they clean the air and do all kinds of things to the soil, but they create all these secondary compounds that are so helpful to us.
That are so helpful to us. I was reading a review a while back in the Journal of Natural Products, which is a scientific journal, but it was a review on drug discovery and natural compounds. In the drug discovery realm and pharmaceutical research, there's always a tendency to say, it's too much trouble to go to the rainforest and collect plants. We can just hire chemists and they can synthesize things in the laboratory all day. And we'll just, and we don't have to negotiate with indigenous peoples about intellectual property rights. Everything we invent is our own. And, we don't need plants as sources of new drugs, even though we've only looked at only about 10% of all plant species as sources of new medicines, new drugs.
Remarkable.
But this article was pointing out that between 1981 and 2002, which is the era that they have statistics to cover, there were about 827 new compounds, truly new, what they call in the industry, new chemical entities or new molecular entities that went from discovery to the clinic. In other words, discovery to through all of the regulatory hoops, all of the screening hoops, and so on, to become actually approved by the FDA as a new drug. Of the 827 or so compounds that went through this process, 61% were natural products.
Wow.
So, it just doesn't, the notion that we don't need natural products to provide the ideas for new compounds, it simply doesn't wash.
Well, on the other side of it, the technology side, people have this idea, too, that technology is sort of a new thing, that I don't know, maybe the Industrial Revolution, but technology, of course, goes back to the chipping of the first stone or what?
Right. It depends. How far back do you want to go? Yeah. The Clovis point is certainly a technological artifact. What does seem to have made a difference since the Industrial Revolution, and now we're seeing sort of the next turn of the spiral with the coming of the information age is the acceleration of technology.
Right.
And I think that is one of the things, it's both frightening and encouraging. The reason it's taking place is because the density of information that we're surrounded by has increased exponentially. And first with the printing press, and then with mass media like radio and television, now with the internet, we're just sort of, riding on this sea of information and sometimes drowning in it.
Yeah.
It's very hard to keep up with a lot of this, and yet, this is what is driving the acceleration. I am sure you probably even had Ray Kurzweil on your program.
Well, his partner, Terry Grossman, has been on the program. I've never interviewed Ray, but I'm very familiar with his work, yeah.
Okay, well, I think he is one of the sort of leading lights that is articulating this notion that we are heading, full tilt towards some sort of technological singularity, or some sort of singularity where the rules of the game become so radically transformed that the world won't even resemble what it resembles now. And I'm not sure that I buy it completely, because I don't think that the world can be sustainable in the absence of nature, at least not given the level of technology that we have now. We're not in a position to build space colonies. We're not in the position to, build generation ships and send them out into the galaxy in search of a new home. I mean, we're stuck with the one we've got for the moment, and we have to pull our act together.
I think about nanotechnology, and you and I have talked a lot about this actually in the past, but the more I think about it, and I'm in manufacturing during the day, and so we make things, but I'm also getting much more interested in molecular manufacturing and this sort of thing, which essentially is just an aping of nature again. I mean, eventually, what seems to be the goal is that we could build things the way nature does, so we would no longer have to do all these things that are so devastating to the environment just in order to make stuff.
Yes, that's right. Although we should also be aware that nanotech brings with it its own set of environmental concerns and other types of concerns. But nanotech is definitely coming on. It's not coming on in the way that Eric Drexler and the people that were sort of the pioneers of the idea envisioned it, but it is happening, and it's happening, like all technological advances. It's silly to debate, in a way, whether we will do it. We will do it, right? If it's within our capability, we will do it. If these things are going to happen. This whole debate that's growing up now around synthetic life. If we can build synthetic life, we will build synthetic life. So the thing to put in place is not stop it, because we can't stop it. There'll always be a mad scientist somewhere, who will do it if it's within capabilities. So the thing to do is to go forward with your eyes open, be clear about both the upside and the downside of these types of technologies. And I think we're right at this stage right now with nanotech where we were back in the 70s with biotech. And, some have argued that, at that time there was much discussion about whether there should be a moratorium on genetic engineering and recombinant DNA and this sort of thing.
Right.
Well, there really wasn't. And to a certain degree, we've paid the consequences of that. Now there is concern that these genetically engineered organisms are escaping into the environment, contaminating wild genomes and this sort of thing. We're at the point now where we can be clear about technology. It hasn't really escaped from the lab, although it in some minor forms it has, but we need to be asking the questions now what are the dangers of it? What are the advantages of it? What can it do? What should it not do? Ultimately it comes down to human choice. I've always argued strongly for the notion that no thing, no technology, no technique, no object has moral qualities. Only human behavior has moral qualities.
Right, how we use all these things.
This comes up in the drug discussion all the time, because the discussion about psychoactive drugs, on the policy level so often has to do with the demonizing of the drugs, as though the drugs had will and behavior, as though they were, somehow evil, intelligent entities. Drugs are simply chemicals. They have a certain action on the body. How humans use drugs, that's where the moral issues come up. And very much the same thing comes with nanotech or any other, or biotech or any other type of technology. It's always a two-edged sword. It can be used for harm or not, and it's never really one or the other. There's always advantages and disadvantages. Just speaking of nanotechnology, I think Scientific American just brought out a special issue on the topic. If anybody's interested, it's on the stands now. I just read it. Some good articles in there.
All right, in the most recent Scientific American.
Yeah, I think it was either the regular issue or a special issue. Okay. I just got it off the newsstand, but it's there now, and some really good articles which were useful. Some of them are kind of dense, but it's useful in terms of getting a perspective of, this is real nanotechnology. Right. This is what is actually being done, rather than the sort of science fiction vision of Drexler. Not that I'm criticizing him. He had the vision, but, there were certain things that were glossed over. One of the big challenges for nanotech has always been the notion of how do you build the assembler, which is this postulated machine that can replicate itself and make more and more assemblers, because you can't really do it with atomic force microscopes. You can't make these things one by one. You have to be able to make trillions of them at the same time, and that's what they're working on. And of course, biology still, biology is nanotechnology. It's the closest model that we have. So, I think a lot of nanotech, as it eventually emerges and becomes more important as part of our daily life, it's going to look a lot like biology. It's going to be biomimetic, as they say.
Amazing. Everybody, it's top of the hour, midnight straight up. You're listening to Radio Orbit on KOPN 89.5 FM in Columbia, Missouri. My name is Mike Hagan. We're listening to our good friend Dr. Dennis McKenna on the line with us from Vancouver, British Columbia. Dennis, what about nanotechnology and medicine? Are you seeing similar effects in that particular realm?
Absolutely. Well, yeah, this issue of Scientific American discusses that quite a bit, because obviously one of the most important applications is for medicine, initially for diagnostics, because you can, even with the techniques they're exploring now, you can build tiny sensors that essentially can go into cells, or you can apply cells to them, and they can detect, for example, cell surface markers for tumors and this sort of thing. Another aspect of nanotechnology, it turns out that DNA is a great material to work with. We think of DNA as what carries the genes, and it replicates itself and all that, which it does, all those things. But chemists are using DNA essentially as scaffolds to build these nanomachines, and there's quite a bit of discussion of that in this special issue about how DNA can be sort of repurposed, reverse engineered, if you will, to nanotechnological applications.
God, the whole thing is just so sci-fi. You know, when I just
Really
close
is.
my eyes, it's like, oh my God, it's like a psilocybin experience or something, because you see the twisting geometry. I can almost see it in my head. You know.
Yeah. Yeah.
Man, oh man,
Which of course raises the issue of, you know, what do you see when you take psilocybin? What are these things? I mean, they do, on some level, seem to be machines or, you know, super technological artifacts of some sort. You can't really tell, but in a way, it's like, you know, the human imagination reaches toward this notion, these notions. I mean, nanotech and really all technology, if you think about, emerges because somebody imagined it.
Somebody dreamed it up.
Somebody dreamed it up. They first had an idea, right? They had an image, and then they realized the image or actualized the image in the physical world. You know, maybe they simply had an idea for, well, if I cut this stone a certain way, it'll be sharper, you know. And, I mean, that's not a very... You know, it's not a very far out idea, but it's essentially visualizing something and making it happen.
Right.
And now we have tools to do that are even more powerful.
Absolutely.
I mean, the sort of the dream of nanotechnology, where, you know, we're there with information technology, although it's not that isn't perfected, but we're able to move bits around. We're able to move information around in very efficient ways and put it and configure it exactly as we want to. That's the dream of nanotechnology, except we want to be able to do it with atoms.
Right.
You know, instead of ones and zeros, we want to actually be able to move physical building blocks of matter around in these very precise ways.
Amazing. You know, we spoke a little bit earlier about cancer. You know, it's been an interest of yours for a long time, I know. But do you think that we're close? I mean, do you think we're going to do we have a chance to cure this stuff?
Well,
I mean, it's amazing to me that we haven't yet, frankly.
It is surprising. It's surprising, especially when you consider, you know, of all the wars that have been declared on this, that, and the other thing, the war on drugs, the war on terrorism. Nixon declared the war on drugs around 1970, I believe, and about the same time he also declared the war on cancer. And what does it say? Both have been spectacular failures.
That's for sure.
Actually, I mean, in some ways, cancer therapy has not advanced much beyond what was available. My mother died of cancer in 1970, and the techniques that they were using to treat her were radiation and surgery and chemotherapy. And this is essentially the same techniques that are being used now. The chemotherapeutic, there have been some advances. There are better chemotherapeutic agents, although that many are still pretty toxic. So
they've gotten better at on the diagnostic side of it.
They've gotten better at diagnostics, and that's a big part of it, because if you can catch these things early, then you have a much better chance of arresting it. I mean, I'm certainly no oncologist, but I think where the real promise lies in cancer therapy is some of these immunotherapies that are coming up, because in some ways cancer is a dysfunction of the immune system. It's basically a failure of the immune system to detect these alien cells at a stage before they proliferate, and there are whole parts of the immune system that are like this internal watchdog because everybody's getting cancer all the time, right? Cells mutate and they start to proliferate, and the immune system targets these things and X's them out before they have a chance to get going. Well, when those mechanisms fail, then you have cancer. And what's interesting about, well, there are many interesting things about the immunotherapies, but the most promising immune therapies for cancer go straight back to traditional Chinese medicine, because these medicinal mushrooms, such as reishi and turkey tail, Trametes versicolor, and all of these mushrooms that the Chinese medicine has used for thousands of years medicinally, it turns out they contain a group of compounds called polysaccharides or beta-glucans. They're these polymers made of sugars, basically, but these materials are strong immune stimulants, and they are being used to sort of activate the immune system. And they have been used in clinical contexts in China and Japan for a long time. There are even medications on the market in Japan, one called PSK, that is a highly purified form of one of these polysaccharides, one of these beta-glucans, and it's routinely used in cancer therapy in Japan, along with conventional therapies. But we're only now beginning to sort of put the science under that and understand how these things work. I was involved in a project before I left the University of Minnesota. I was sort of peripherally involved in a multi-year, multi-center project looking at Trametes versicolor, which is called the turkey tail mushroom.
Okay.
One of the better research mushrooms that's being used for this.
Interesting.
And it turns out it's not only mushrooms, it turns out everything. Virtually all plants, bacteria, fungi, yeasts, which are a kind of fungus, photosynthetic plants, aloe vera, they all have these polysaccharides, these immune-modulating polysaccharides.
Well, it's interesting. There are two things that sort of come to mind. First of all, my intuition is that it's going to come from a plant. There's going to be a cure that comes from a plant. But there's a friend of mine who researches a particular mushroom called the cordyceps sinensis, I think it's called.
Sinensis,
that's what it is, yes.
Yep.
And he's had some encouraging results and responses from that particular strain of mushroom, too. At any rate, well, I'll tell you, how about we take another short break and we come back and do one more segment?
Sounds good.
Sound good? All right, it's Mike. You're listening to Radio Orbit on KOPN Columbia. My guest is Dr. Dennis McKenna. You can find information on the web about Dennis. You know, Dennis, I suppose I should give out the Hefter address, but is there anywhere else that you like people to go in?
Yes, the Hefter address, definitely, which is www.hefter.org. It's HEFFTER.
All right, Hefter.org. And you can also find a lot of information about Dennis and his work at my site. We've had a number of previous programs. One last year in May, I guess, with Richard Glenn Boyer, which was very interesting. A wonderful program with Stephen Herod-Gunner a couple of months before that. And then Dennis was on back, believe it or not, back in 2004 in November. So lots of great stuff there in the archives. And if you like to dig around in there, I'm sure you'll find some gems. Okay, Dennis, thanks for sticking around.
Okay.
All right, let's see here. Where should we go? A lot of folks are asking about 2012. But the time wave and all that business was, for the most part, Terrence's baby, and I don't really expect you to speak to it. I would, however, like to ask you just about your general sense of the future through your own lens and the work that you're doing, and the relationship that you have with other people in all these interesting fields.
Yeah, I mean, it was basically Terrence's baby. It was his idea, and I think it has a lot of merit in certain respects. I think that he has certain insight into the structure of the I Ching. I'm kind of one of the chief skeptics, though, when it comes to the claim that it actually describes the structure of time. I think there are so many holes in that argument. It's very difficult to defend that notion. But in a larger context, I think there does seem to be a great deal of expectation around 2012, whether you're coming at it as a fan or a devotee of the time wave, or whether you're into the Mayan calendar, all of these things, many things. There's a great deal of sort of millenarian expectations around the 2012 date. And I don't know what to make of it. I'm kind of skeptical. I mean, I'm actually quite skeptical. And in a way, I think I'm not even sure that this speculation is that healthy, because it's a certain, it's a strategy for not facing up what we're faced with. I mean, it's really, in some sense, it's no more constructive or useful than the expectation that Jesus is going to come and save us, or our alien brothers are going to come in starships and save us. Maybe so. I mean, we can all hope for that.
Right.
We shouldn't count on it,
right,
because most likely it's not going to happen. So in a way, this is another head in the sand strategy. Let's just all wait around till 2012, when there'll be this tremendous wave that will change consciousness in a global sense. I mean, God, I hope so.
Right.
But I'm too old, and I'm too much of a cynic, basically, to put much faith in that. I mean, when people say, well, what's going to happen on 2012? My response is, we're very close. Let's wait and see.
Right, at this point,
don't cancel your appointments for 2013.
Yeah, it is sort of like many things. It can have a cop-out-ish side of it, sort of where you think, well, I guess we don't have to do anything.
The human species has tremendous ability for denial, right? And for sort of, when reality is staring us in the face, we can, we're very good at just denying that it's there. Look at the whole global warming issue, or look at what our government does on a daily basis. I mean, talk about not being based in reality, and yet, because they are who they are, and obviously their pronouncements are not reality-based, but the rest of the world is forced to deal with that and take it seriously. So, 2012, who knows?
Yet we are in a situation, as you say, and we are close. We're 5 years away.
Right.
And we do have a lot of situations in many different areas that are sort of reaching critical. Something's got to give, it seems.
Well, it seems so. Yeah, I mean, a lot of things seem to be reaching critical mass, but the trends that I'm seeing, there's a great deal of hopeful expectation around 2012. The trends that you can read about in the newspapers daily are, things are not hopeful.
Not quite so hopeful.
There could be a critical change, but not particularly one that we would welcome.
Everybody sort of agrees that changes are coming, but the question of whether they're going to be the New Age lovey change has not been determined. I mean, I don't think there's any way to. Certainly, as you say, the reality of the news of the day doesn't seem to point in that direction.
No, and there's really no way to. Obviously, there's no way to know it. If you look back through history, the number of critical juncture points of history that have been fairly grim far outweigh the number of junctures that have been hopeful or optimistic. And again, it comes back to essentially our place in the cosmic scheme of things. We have only one planet. It's a very fragile ecosystem. We don't really know if we're the only ones in the universe or not. Probably not. Reason would say that, probably not. What is it about us that makes us unique? But we don't have any actual evidence that there are aliens, that there are others out there. So we're pretty much stuck. Even if they are, the distances in time and space are so vast. I mean, if you discount the whole UFO phenomenon and all this other stuff, which I'm not automatically discounting it, but I think that, the level of evidence, it all comes down to this, Mike. I don't know who said it, but I firmly believe it. Extraordinary claims require extraordinary evidence.
Right.
And, I haven't seen the extraordinary evidence that supports these kinds of claims.
Right. Yeah, I agree with you. And I also think, though, that one of the things that I think would be helpful is that extraordinary claims also require extraordinary investigation, I think.
Yes.
And sometimes you don't get the investigation that you might like to get from, the people that might have the means to do it. But at any rate, all right, let's move along just a little bit. By the way, Dr. John Sheliak, who's listening to the program, says hello.
Hello to him.
Speaking of the time waves, yeah. John,
right.
He's wonderful. John and I have become friends, and he's...
and he's been on your show.
He has, yeah. He actually he was actually here in town last weekend, and he spent a couple days with me at my home, and we had a wonderful time together. He's a wonderful guy. So.
Right. I've never met him, but I've read some of his material, and actually he wrote me an email not long ago saying that he would like to put some of he's been working very assiduously on the time wave.
Yes.
Being a mathematician and a physicist, I think that, if anybody can put legs under the time wave, he might be the guy to do it.
Yeah,
I have an open mind, and I look forward to seeing what he comes up with.
All right. I won't speak for him, but I can tell you that he certainly has he's working for sure, and he's very interested in continuing the work. And I think that's interesting alone because he is a very intelligent guy, and if he thought there wasn't anything there, I don't think that he would continue with the effort that he's continuing with. But
quite right.
At any rate, okay, maybe there's a radio program there in the future. I don't know. You and Dr. John, I could see that happening.
That's possible.
All right, well, we'll see. Okay, the word planet, you make me think, and then the word plant, we've been talking, they're very close, the two words. The 2012 business, the social and cultural crisis that we're in the middle of, are the plants an ally that can help us get through? And I know your answer, but of course I'd like you to talk about it.
Well, yes, obviously my answer is that they are. I think the third word that is part of that trilogy is plan, right? Plan, planet, plant.
Yes.
And it may be that, people that are familiar with the use of these psychotropic plants and shamanic traditions and, their traditional use in the context of shamanism will tell you that it's just sort of a given, it's really conventional wisdom that these plants are intelligent, and the plants are in some ways messengers from the community of species, I think, is one way you could put it, a way that the community of species has evolved to, in some ways, communicate with this out-of-control ape that's somehow gotten loose on the surface of the earth, with this hypertrophy brain, and, is running amok. And the plants, the psychotropic plants, the psychedelic plants, are there to sort of say ease off, or wake up, or, consider your origins. So, yes, I definitely think that, the psychedelic plants play a very important role in sort of the evolution of consciousness at this cusp in history. It may be, they may be one of our only hopes. So, I do agree with that.
So in a sense, the plants really aren't just chemistry.
Well, the shamans will tell you that they're not. No, they're not just chemistry. That's not our subjective experience when we encounter them. Absolutely. There are obviously chemical properties that the plants have that give them the unique ability to interact with our neurochemistry in a certain way. So they are chemistry, but it's not just chemistry.
Okay.
But, again, what is just chemistry? What is matter anyway? And the fact that matter can have these qualities. Look, for instance, at a compound like DMT. It's a very simple compound. It's 2 steps from tryptophan. And, you know, early on when I was interested in these things, one of the things about DMT, the experience that it can elicit, one of the things about that impressed me most was, well, you know, if a simple molecule like this can do that, then maybe there's more to just chemistry than we imagine.
Yeah, you've made it actually in a very comical little segment that you had on a show we did with Stephen Buhner. You made it really clear that essentially that's all what we are. We're just chemistry. And
well, obviously we are.
Yeah.
Right.
Yeah.
Right.
Okay.
I mean, in my lectures, I sometimes mention to people, you know, the notion of a drug-free America or a drug-free school is completely absurd because we are drugs, and we're made of drugs. And I thought this was an original observation. It turns out Salvador Dali said this.
Wow.
I am drugs, he said.
Amazing.
And so he got it.
He got it for sure. And look at his artwork, you'll get it.
Right.
All right. Dennis, a listener says he considers you a quote-unquote reluctant shaman and asks what it would take for you to reevaluate the events of 1971 in La Chorrera. Is there anything that would ever make you go back there and relook at the stuff that happened?
Well, what do you mean, re-evaluate it?
I don't know. I think I can't speak for him. And the way I'm interpreting his question is that is there something that might happen that would make you say, wait a minute, we actually were on the ball back then or something?
Well, if something that ruptured plane on December 21st, 2012 happened, I'd have to take a second look at it. You know, if the violet crystal lens were to materialize in my backyard and the doorway slide open, yeah, I'd have to reconsider it.
Okay, so that's what we're looking for.
But I don't expect that to happen anytime soon.
All right.
I mean, I'd love to be surprised.
Yeah, I think so. I think all of us would. All right. Let's see. Here's one that just comes up that's sort of a biological one. Dennis, are there more serotonin receptor sites in the gut than in the brain?
I don't know. I've heard that there are, but I'm not sure where that information comes from.
Okay.
It's a good question, though. There are serotonin receptors all over the body, and in fact, serotonin was first discovered as a hormone helping maintain vascular tone. That's what it means, serotonin, you know, in the bloodstream and having hormone-like effects before it was ever discovered in the brain. But the same is true of many types of neurotransmitter receptors. I mean, there are, for example, all the opiate receptors. Most neurotransmitter receptors are well represented in the gut. You know, which makes sense because the gut and the neural structures come from the same embryological origins.
Okay. Here's one that's a personal question from me, okay?
Okay.
I've been experimenting with you know, I like to grow things, and I'm always messing around with my plants and mushrooms and stuff like this. And I became familiar with this guy whose name is Luther Burbank. Do you know who he was?
Oh, yes.
Right?
Yeah.
Well, I was fascinated by his story because scientists, for the most part, looked at him as sort of a heretic or something, yet he was very successful in doing what he tried to do in creating these new, essentially new species of plants.
Yeah.
I don't know. I guess I'd like you to talk to that a little bit.
Well, he was an inspired botanist. I mean, he is one of these figures. He's a bit like, he is a bit to the plant world, the same as Nikola Tesla was to the world of engineering. You know, I mean, Tesla was a visionary.
Yes.
He imagined all these machines, and then he created these machines. But
Yeah,
he's a total gone visionary.
Yeah, one of my heroes, yeah.
And Luther Burbank was much the same, that he just seemed to have the touch. I mean, it wasn't simply a green thumb, you know, there was something about him that he had an extraordinary talent for growing plants and for breeding plants, and he was just a genius of the plant kingdom, of plant breeding.
And this is long before genetics and any of that sort of thing.
Oh, yeah.
Right?
I mean, yeah, purely Mendelian. He was able to do it all with just Mendelian genetics.
How can we do that?
How can we do it?
Yeah.
You know, I mean, with people like, sure, we can do it, but people like that, they just have innate talent.
Mm-hmm.
I mean, that's what genius is. How can you, that's like saying, well, how can we be like Tesla? Well, you know, I don't know. I mean, I think you have to have a certain talent, you have to basically be a genius, and then you have to have the ability to, you know, acquire the tools, the knowledge that you need to apply that genius. And these guys were just in the right historical time and place to be able to do that.
All right. Okay. What else you got on the docket? What's happening in your world? You got classes that you're teaching? I know sometimes you go to Hawaii in the wintertime.
No, I'm not teaching any classes here at BCIT. This is all research, although there's a lot of teaching that goes on here.
I'm sure.
I'm not part of it, which is kind of disappointing because I do I enjoy teaching. And yes, my course in Hawaii is going forward. We're pretty much fully booked for this year, and this will be the 5th year straight that we've done it. So
Still titled Plants and Human Affairs?
It's called Plants and Human Affairs, and of course my co-teacher on that, my co-instructor is Kat Harrison, who is Terrence's ex-wife. We're still getting along fine, and
Good.
we're looking forward to teaching that. We're actually considering offering some version of it in Peru next summer.
Yeah, you mentioned that to me. Yeah.
I'm enthusiastic about the idea. I want to do it, and Kat is. I'm trying to convince Kat that we should do it.
Wonderful.
You know, she's also enthusiastic, but it's like it just seems like so much time, and it's quite a challenge to get it going. And I say, well, if we start now, you know, we'll be ready. So yeah, I'm hoping we can do that. I still have my affiliation with the University of Minnesota. I may go back there in a few months. I'm not convinced I'm going to make this trip to Canada or this move to Canada permanent right now. But it hasn't been a bad experience at all. It's mostly personal reasons that would take me back.
Have you been to Peru this year?
I have not made it to Peru this year. I was hoping to, but probably early next year.
Okay. All right. How about one last question here that just came in via the web?
Okay.
A gentleman or a gentlewoman asks about, and just says, please ask Dennis about access to holographic memory via psilocybin.
Okay.
I'm guessing that they're sort of making an assumption that when we take psilocybin that we have access to some sort of, you know, Terrence used to talk about the Bell non-local spaces and this sort of thing. I guess maybe is that what you think might be happening?
Well, possibly. I think that psilocybin and these other things give you access to some kind of an archetypal constellation of information. I don't know. I mean, you might be able to characterize it different ways. You could call it holographic memory, or you know, the collective unconscious, or the Akashic records, or whatever. But I think there's little doubt that, you know, there is a tremendous repository of information that is accessible many ways, and most of the time is not accessible. If it was, you know, we wouldn't be able to navigate in the day-to-day world. I mean, that's one of the things that these things do. You know, Huxley's original idea that, you know, somehow mescaline opened what he called the reducing valve is, I think, a very valid model. You know, we've discussed this before, I think, on the program, to the extent that, you know, the brain synthesizes reality, and then, you know, we proceed to live in this confabulation that the brain constructs. You know, the hallucination that we've all agreed to call consensus reality. And it has its uses. It maps close enough to ordinary reality that we can navigate. But under certain circumstances, it's an impediment because it keeps us from appreciating or apprehending all of this other information that we normally filter out.
Right. That's very valuable and pertinent to our own
valuable
situation.
in its own when it's apprehended under the right circumstances.
Right.
So that's one of the importance of that's the importance of set and setting, for example, in taking psychedelics, so that you can establish a setting that where you don't have to worry about basic survival issues. So then you can just let your defenses down, your ordinary reality mapping, and let it all flow in. And what it is, I don't really know. Holographic memory is as good a good way to characterize it as any, I think.
Okay. All right. Well, I have to say thank you, and it's been wonderful as always. And
always a pleasure.
Yeah,
Mike.
Dennis, you do great work, and we're all appreciative of everything that you do and that you've done. Please give our best to your family and to Kat and to Clea and Finn, and hopefully everybody's doing well.
I will do that.
All right, and we will be in touch next time around, okay?
All right. All the best.
All the best to you. Thank you very much, Dennis.